All right. First question I have for you all. There's the question. When would you use the midpoint of a class? Don't look at your notes. This is what you're supposed to be doing outside of class. It's called reviewing. When would you use a midpoint? What is a midpoint? How do you find it? It's like the average, but how do you mean like the average? No, don't go back looking through your notes. I said I don't want you to do that. That's what you do outside of class. When you leave class, you go home and study instead of surfing your phone all day long. That's a waste of your time. Just get away from that junk. When would you? What's that? Well, that's what the midpoint is. It's the middle of what? No, you can't. Now you have two different things of the class itself. But okay, now what is a class? They're using words now that are incorrect at this stage. What's that? Nope. You're looking at class literally, like this is a class. No. In class and statistics, probabilities, what is it? No. The sum of every, what okay, what is a population? It's the total group of data. You can't say a group of, because that could be a sample also. But a population is a specific, it's everything in that. Whereas if we take the population of America, that's everybody from one side to the other side. It's everybody in America. That's the population. A sample would be people in this room. But what is a class? When do you use a class? Here's an easier question. Have you guys even looked at your notes since last week? Then why do you take notes? Why do you waste your time? Why even take notes? You never look at them. You don't know what's in there. Why do you waste your time and take notes? That's an easier question. You guys should know that. Okay, go and look back at your notes. Let's use them. Let's put them to use for something. When do we use class? A class is used to define the X values of a range. If you have a large data set that has a very wide range from 0 to 1,000, you form them into groups. That's when you use grouped. Classes are used in grouped data. What do we mean by grouped? When we talk about groups, they're within some sort of interval. These are the classes. They're the intervals where your data will fall. Okay, we're still getting to the point. What is a midpoint? Not like, I use the word like in this room. It's either going to be something or it's not going to be something. I mean, it's in the word itself, midpoint. Middle of what? Ah, yes. So in the first class, what's the midpoint? How'd you get that? The midpoint is defined by x sub m, because these are your class defines all your x values. You add the two values of your class and divide by 2. It is the average. That's the midpoint, halfway between them. So what's the average? What's the midpoint of this first class? You said 2.5. What's the midpoint of the second class? Maybe what? We just talked about how to find it. Is equal to. How would you get the next one? Is there another way? It's faster than that? Yeah, because to go from the lower end, go from 0 to 5, how do I do that? How do I go from 0 to 5? From 5 to 10, at 5. From 5 to 10, 5 to... So each one of these are 5 apart. So therefore, the midpoint of the first one, if I added 5, I'd get the midpoint of the second class. And the next one would be the same thing. And the next one would be the same thing. Add 5 to it. Then we have the frequencies of these. So why would we need to have the midpoint? In a sense, yes, but not exactly right. But you're right. I mean, it is one of the side effects. How do we find the mean of this data set? If we have intervals, how would you find the mean? What is the formula for the mean? What is the mean? The mean is the average. What's n? How do I find n? But if you look at this formula here, it won't work for classes. Actually, it should be X, not F. Let's add up all the data. Because all the X's are here. So what number do you put in there? You can't put 0 and 5 in there. That's why you use the midpoint. This midpoint represents each of those classes. So this midpoint is representative of that class. This one is that class. Because this formula says to find the mean, now why is that? Why is F times X? What does that represent? What's that? Yeah, you're just telling me what they are, but what does it represent? I know what F and X are. I put them there. I want to know what it represents. From elementary school. What's faster way of adding all those numbers together? What's that? Multiplying what? Right. The numbers, the common number is 3. It occurs 7 times. So the answer is 21. Instead of adding all these, I can just multiply them. Basic algebra from elementary school. That's what this says. Instead of adding each of the numbers separately, this is my X. This is how many times it occurs. So what this represents, this is adding up all my data that I have and divide by how many I have. That gives me my average. It still hadn't answered a question. When would you use a midpoint in the class? You'd use it to be able to do any calculations, because you cannot use a class for anything except finding the mode. Then the reference to the modal class. Okay, so how about what is a relative frequency? How do you find that? How do you find a relative frequency? Wow, you guys weren't joking when you never look at your notes. What is a relative frequency? Why is it called relative frequency? to overall data. Very good. Yes. Well, we want to see, because it does repeat itself. Let's say the data we're in 1, 2, 3. These are my data. The relative frequency is each frequency divided by how many? I want to know what is the ratio of this data compared to everything in general. So the first thing we have to do, how do we find n? By definition, n is the summation of all your frequencies. N is 15 in this case. So the first one is 3 divided by 15, which is the same thing as 1 over 5, which is 0.2. The next one, 5 over 15, which is 1 over 3, which is 0.33. Then we have 4 over 15, 1 over 15, 2 over 15. We want to see, now, why would you need to know that? When would you use that? Do you have any graphing techniques for that would work? Absolutely, yes, you could. I mean, you could. When you create a relative frequency, a table, this is what's called a relative frequency distribution. And we could do the same thing there. With all of our x's, we could refer them to the decimal equivalents. Instead of having the n value, the frequency value of each of those data sets, we have those. But yes, okay, so answer your, yes, we could do that for a relative frequency distribution chart. Not a histogram. Histograms only work with frequencies. This would be dots. How about, have you heard of a cumulative frequency? So let's pretend we have our data set back over here. 1, 2, 3, 4, 5. Three, 5, 4, 1, 2. How would you find the cumulative frequency?
First, I would do this number, then
So,
I go down, and then I add two numbers together, first two numbers together,
okay, so what I put here,
3,
then
then plus 4, 12, then 13.
very good. Cumulative simply means running total. It's from this point on down, how many numbers are there? There are 8 numbers. There are 5 here and 3 here. From this one, how many data points do we have? We have 1 plus 4 plus 5 plus 3 is 13. That's what it tells us. How about a cumulative relative frequency? How would you find that column? How do you mean? So here, okay, so the cumulative frequency would be 3, 8, 12, 13, 15. So what would be the cumulative relative frequency? It's in the words, it's in the name. Cumulative. What does cumulative mean? What's that? Okay. It's collective. What's it running total? Yes. Of what? Running total of what? Do you have a relative frequency? So how do you find a relative frequency? How? Not yet. Relative frequency. We just did that about 10 minutes ago. What is a relative frequency? It's relative to what? Yes. It's the frequency divided by n. So what's our n? Our n is 15. Add up all these first, all the frequencies. Okay, calculate each one of those. And you have to understand how many decimal places are you going to use? 2. Everybody should be writing this stuff down because hopefully by writing it down, you'll at least learn something. Because God knows you never look at it once you leave the door. So what's the first one? 0.02 or 0.2? 0.20. What's the next one? Next one? Next one. And the next one. Very good. Okay, so we have the relative frequency. So the cumulative relative frequency would be what? Yep, that's what cumulative means. It's a running total. So what goes in the first box? Then what? Then what's the next one? Then so whenever you look at the frequencies, the relative frequencies, if you add them all together, they better equal 1.0 because it's the ratio of each one individually over all of them. What would that graph look like? If we graphed the cumulative relative frequency, what would that look like? Like a what? How do you mean? Skew only works when you have, well, you can. A skew, what kind of skew then? No. Well, yeah, if it's not right, it's gotta be left. What we're doing here, starting at 0, go to 1, 2, 3, 4, 5. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. It's a running total. But because it's a running total, it's going to be an increasing graph. So at the first one, we have 0.2. So we have that connection. At 2, we have 5.3. So that's up here. It's increasing. Then we have 0.8. It grows even more. Then 8.7. Then 1.0. It's always going to have that shape. It's increasing, which is also what's called an ogive. An ogive is an increasing, a progressively increasing graph. Starts with the lowest and goes to the highest. Let's look for an example we have here. And OGIVE looks at the cumulative effect of your data. Two, 4, 6, 8, 10, 14, 16. So at 1, we have a 3. Then we go to 8. Then we go to 12. Then we go to 13. And then we go to 15. So it's always an increasing graph. I mean, either way. Right, then it'll be decreasing. What you want to do here is it shows you the change between each of your individual variables. Okay, we talked about those. Have you ever heard of a Pareto chart? Let me get the data here. Okay, with this data set, we're looking at the excess amount of produce at a store. A Pareto chart is just the opposite. Like you asked earlier, can we do it backwards? An ogive is an increasing graph. A Pareto chart is a decreasing graph. So what we would do, we would take this data set and start it from the largest and going to the least. So what would be my largest in the first column, in the first row, which is vegetables? Then it would be, so that one's taken care of. That's at 36%. And then cereal. And now you would graph it. Vegetables, meat, milk, fish, and cereal. So the vegetables would be 44%. And the meat would be 36%. And the milk would be 32%. Then 30% for the fish. And then 27% for the cereal. Then the question you should ask is why? Why does it matter in which the direction it's going? Whether you're using a Pareto chart or if you're using an OGIVE, why would they, what would be the benefit of one over the other? Yeah, there's the difference between an OGIVE and the Pareto is, yeah, with this one here, again, think of an example would be a construction or a business. I want to see what sells the most. Or in this case, in this one, it's excess amount. Which items did we over order? This could be how much stuff do we have extra in our storage room? So be careful how we reorder next time. No, it could be anything. It could be, it could be if you're counting the number of first place finishes by a country in the Olympics. Actually, that's what you always see when you see the Olympics. If you ever watch the Olympics, you'll see the medal count. You always start with the highest medal count going down from there. That's a Pareto chart. So you look at it and you know which country has the most. You start off with them, and everybody else just goes below there. So it could be rearrange it anyhow you order. I mean, it can be rearrange it, but it could be anything you're looking at that you want to look at. What's a time series graph? What do you think, just by the name of it, what do you think a time series graph is? And don't go looking for it. No, then that could just be a relative frequency chart or a time series graph is just that over a span of time. So on and so forth. For example, athletes, they want to see how fast they could swim a mile or run a mile or things like this. We wouldn't put it in years. Me running it'd be that much, but you say in the year 2000, how many first place finishes did I have? I had 3. In the year 2001, how many first place finishes did I have running? I had 4. Then I had 1. Then I back up. That's a time series chart, a graph. Well, I look over time, what happens at each time interval? You can have it what's called a comparison time. Where you can compare 2 different things. two different people. A perfect example people do is over the time, it could be in months. What is my budget? How much do I spend per month? How much do I spend on entertainment, on food, on gas? Be a perfect project for you all. Look at how many text messages you send per week over the series of time, over 2 months. See how many text messages you sent each week. And then we go even further, how much time did you waste during those 2 weeks sending those messages? Compare them between necessary, which would be down here, versus benign, mindless chatter with friends. Once you see how much time you waste doing that, if you want to be productive, you would cut it out. A lot of my friends and colleagues erased all their social media. I don't care what somebody's eating for dinner, or I don't care about seeing somebody taking pictures of themselves every 5 minutes because they love themselves that much. That has no interest in me. Do away with that crap. The time you save now, you could put it to something more productive. That'll increase your income. That'll increase your productivity. So, I mean, time series is a perfect study that you could do on yourselves. If you ever get into an exercise routine, how many sit-ups can you do? How many push-ups can you do? Each week, does it increase? A pie chart. What does a pie chart do? Not the pie chart. That's a standard deviation, standard variance. What is a pie chart? Okay, so what do each of these pieces of you see why it's called a pie chart? The circle represents a pie. How big piece of the pie did you take? Perfect for budgeting. This is for food. This is for gas, entertainment, medicine, other necessities. What it does, it puts it into a percent of this circle, how much is in there, by defining it in X number of degrees. So this part of the circle could represent 34% of my income. And that's what that is. But how do we go from percent to degrees? Well, first off, it's a whole mathematical process. What is a percent? No. An average is an average. What's a percent? Because how do you find the average? You add them up, divide by how many you have. That's average. You don't do that here. So what is a percent? Because we have our data here. How do we go from there, from this, to determine a percent? Because we need to know the percent in order to find a degree. What's that?
Like 3 of 100.
Is that a percent? Because 3/100 is 0.03. That's not a percent. How do you turn it to a percent? How many spaces in which direction? Okay, so if I move it 2 to the right, I get back to 3. That's exactly what it is. Yeah, because when you said 3/100, you defined exactly what the word percent. Cent is Latin meaning centi, 100. It's per 100ths. So when we divide 3 by divided by 100, we get 0.03. And then this is our, in essence, our relative frequency, isn't it? This is how many we have. That's our frequency, summation of all our frequencies, our n. How do we go from here to here? You can't just say move it over 2 spaces. It has to be a mathematical operation. Whenever you have a decimal and you multiply it by 100, you now put it into percents. So a percent by definition is part over total times 100. That equals some percent. So find me the percent of each of these. So the first one, we have 3, or first off, we have to get n. We have 15. So 3/15 equals 0.2. Times 100, we get 20. So it's 20%. Do that to all of them. What's that? So we take whatever this frequency is, divided by the n. The summation of all your frequencies is your n. So we take 3 divided by 15 times 100. So for the first one, it's 20%. Now, I want you guys to do it yourselves. Don't just bobblehead what I'm doing. Do it yourselves. You ever pay somebody to come paint your house and you do it for them? No. What's that? The rounding's already been done. That's when we talked about that. When we do the part over total, we want that to be 2 decimal places. You shouldn't have to scroll if you're using a calculator. This is what if you're scrolling, I know you're not using a calculator. This is the honesty issue I was having. I'm letting you use a calculator, and you decide I'm using my text messaging. I'm gonna see what wasted time I could do now. You should be done by now. We did this already. We did the relative frequency. That's part over total. The relative frequency is your frequency over your n. Take each one of these, multiply by 100, you get 33%, 27%, 7, 13. What's that? When we did the part over total, that's where you round to 2 decimal places. You asked that the first time when we did the relative frequency. I said 2 decimal places. Yes. So that's when the rounding occurs. And then you multiply by 100. So basically, what this is relative frequency times 100. That's the percent. Which is why you have to know how to do relative frequency first. If you add up all those, how much do you get? No, not should be. Better be 100. If it's not 100%, something's wrong. Because all of these have to refer back to the n. Okay, so that's how we get the percent. So we know that for the first one, it constitutes 20% of the data. So how do we go from percent to degree? It's a percent of what? It's a percent of the circle. How big is a circle? 360 degrees. So 20% of 360 degrees equals 0.2 times 360. Because you can't do calculations with percent symbols. You have to convert this back to decimals and then multiply by 360. That's the number of degrees that you have. So the first one, 20% of 360 degrees is 72 degrees. Again, if you use your cell phones for calculators, you should get that. No, because we also want to know what is the percent. Because once we get the degrees, the reason we need the degrees is because when we draw our circle, we start from one line. And then from there, we go up 72 degrees. That tells us where the next line is. So now I know that inside there is 20% of my data. You have to tell me how much is in there. The degrees are simply help you draw the picture. The stuff inside there is still a percent. Now for the next one, what is 33% of 360? So 0.33 times 360? 118 point what? 0.8, all right. So from here, from this line here, we go up 118 degrees, 0.8. And we know that's going to constitute 33% of our data. And we keep on going through the rest of them. That's how you create your circle. So when you finish going through this whole circle, you should end up to the original line. So that's why you need both the percent and the degrees to create your pie chart. Stem and leaf plot. We have this data. The way you use a stem and leaf is, first off, this data is how many digits are we going to use here? Not digits, I mean, how many numbers do we have in each number? In 24, we have two numbers. In 21, we have two numbers. In 11, we have two numbers. What about these guys? How would we write those so it has two numbers? Right. The way the stem and leaf is, think about that. We have a branch. And from that branch, go out the leaves. So on this branch, these are the first digits. We have a 0, we have a 1, and we have a 2. So in 0, this is why also put them in increasing order. You want to put them in increasing order because in the zeros, the first number is a 1, then a 3, and then a 4. In the ones, we have a 1, we have a 2, and we have 2 7s. With the first digit being a 2, we have a 1 and a 4. So that's a stem leaf plot. Pretty boring, but what it's good for, you can see, this is another way you can see the mode of it. Whichever leaf is longest, that's the modal class, modal group. Another type of graph method that we use is called the dot plot. Let's say our data let's say we have this as a data. Okay, we have to put it in increasing order. So on a number line or a horizontal grid, for each number that matches one of these numbers on this horizontal line, you simply put a dot. So we have 1, 2, 3, 4, 5 zeros, so it's 5 dots. We have 3 ones, 2 twos, 1 3, 5 fours, 1 5, and 4 sixes. So it's repeated numbers are stacked on top of each other. In essence, this is a very primitive form of a histogram. Now, what would be the benefit of using this method? Yeah, because that way, in the histogram, you need to have a frequency chart. If you don't use it, this is the same as a tally column. Because as I'm reading along, I just put a dot. Once I finish, I have my frequency column and I have the histogram. Because if I wanted to, now all I have to do is just connect these with boxes. So you can convert a dot plot into a histogram. Yeah, we talk about misleading graphs. Yes, it'd be almost impossible because that's a very, very good question. Because this one you need um, analog data. It has to be a one or not a one. Because if you had decimals, then now we're talking about a range. We could do it that way though. Between 0 and 1, we could say if you had a 1.3, 1.4, any decimals go between 0 and 1 and 2, you could do it that way. So anything that goes in this range. So it goes from 1.0 all the way to 1.999999999. Oh, by the way, if you ever see a number with a bar over it, it doesn't mean mean. It means that number repeats itself forever. If I had 2.47 like that, that would be 2.474747, and so on and so forth. So whenever you have a line over a number or a group of numbers, only the 1 and 5 so whatever has that bar over it is what's repeating. Probably does. That's probably, it could be repeating or that's what it represents, a repeating decimal. But it's only the decimal, not the leading term. All right, that finishes chapter 2. That finishes chapter 2. A little bit longer than I expected, but I'm glad we got it done.